Hello students, welcome to our YouTube channel Experience Tutor. Today we will discuss class 12th physics chapter 1 electric charge and fields part 3, and here is our welcome message. Before we begin, please subscribe, like and share our YouTube channel among your friends and relatives. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever a new video is uploaded. Today's topic is superposition principle. When more than one Coulombian force are acting on a charge, the resultant Coulombian force acting on it is equal to the vector sum of individual force. So this part is important, the vector sum. So when more than one charges are acting, then it is equal to the vector sum of the resultant force is equal to the vector sum of the individual force. Now same can be derived. For example, in the given figure, you can see Q1, Q2, Q3 and Q4 are the charges placed in a system as shown in the figure. Let R1, R2, R3 and R4 are their respective position vectors in the given coordinate system. Here we will find the resultant force F2 acting on charge Q2 due to other charges. The force on charge Q2 due to other charges is the force on the charge Q1 due to charge Q2 due to Q1 is F21 is equal to K Q1 by Q1 Q2 upon R21 square, unit vector R21. Similarly, force on charge Q2 due to Q3 is F23 is equal to K Q2 Q3 upon R23 unit vector 23. The force on charge Q2 due to Q4 is F24 K Q2 upon K2 Q4 upon R24 unit vector R24. According to the superposition principle, F2 is equal to F21 plus F23 plus F24 is equal to K Q1 Q2 upon R21 square unit vector R21 plus K Q2 Q3 upon R23 square unit vector R23 plus K Q2 Q4 upon R24 square unit vector R24. Now K Q2 Q1 upon R21 square unit vector R21 plus Q3 upon R23 square unit vector R23 plus Q4 upon R24 square unit vector R24. We can take we can write generalize this equation K Q2 sigma Z is equal to 1, Z is not equal to 2 until 4 Qj upon R2j square unit vector R2j. Therefore, we can write F2 is equal to K Q2 j is equal to 1, j is not equal to 2, sigma 4 uh, qj upon modulus r2 minus rj whole cube r2 minus rj. The general equation for force acting on the charge qi due to the system of n electric charges will be Fi is equal to kqi sigma j is equal to 1, j is not equal to I, qi upon r ij square unit vector r ij. Fi is equal to k qi sigma j is equal to 1, j is not equal to I until n q qi upon ri modulus of ri minus rj to the power whole q ri minus rj. So this is the generic equation for superposition of forces. Any charge which covers a space with dimension much less than its distance away from the observation point can be considered a point charge. So we can write the definition of point charge as any charge which covers a space with dimensions much less than its distance away from an observation point can be considered a point charge. A system of closely spaced a system of closely spaced charges is said to form a continuous charge. Distribution. It is useful to consider the density of a charge distribution as we do for density of solid, liquid, gas, etc. Now we'll study about linear charge density, which is lambda. If the charge is distributed over a straight line or or over the circumference of a circle or over the edge of a cuboid, etc., then the distribution is called linear charge distribution. Linear charge density is the charge per unit length. Its SI unit is coulomb per meter. Therefore, lambda is equal to q upon L, or lambda is equal to dq upon dl. So if we consider charge distribution, linear charge distribution in this way, and let this small portion is dq and the length of this small portion is dl, then lambda is equal to dq upon dl. So total charge on line L, total charge on line L is equal to q is equal to L lambda dl, integration of lambda dl. So this is the expression for linear charge density and total charge. Next we'll study about surface charge density. Sigma. If the charge is distributed over a surface area, then the distribution is called surface charge distribution. Surface charge density is the charge per unit area its SI unit is coulomb per meter square. So let us consider charge is distributed here on the surface in this way. This small portion say this small portion is dq and area of this portion is ds. Now sigma is equal to q by s, or sigma is equal to dq by ds. Total charge on surfaces s q is equal to integration of s sigma ds. Now volume charge density. If the charge is distributed over a volume, then the distribution is called volume charge distribution. Volume charge density is the charge per unit volume. Its SI unit is coulomb per meter cube. Now let us consider a cube which is equally distributed charge on it. Now we'll find out the volume charge density. Say this portion, small portion, this small portion has a charge is equal to dq and ds in the ds surface area is equal to ds. So density rho is equal to q upon S, or you can say dq upon ds. Total charge on volume is equal to q is equal to integration s rho ds. And this is the end of today's topic. Before we close, we request you to subscribe, like, and share this channel to your friends and uh, relatives. Please click on the subscribe button to support us, and also click on the bell notification to get automatic updated when a new video is uploaded by us. Thank you very much. Support our channel. Please give a comment and like sign if this is helpful, if this are helpful videos to you for you. Thank you very much.